so let's see if we can go ahead and knock out this next part of the tutorial here. It is the walk animation for the enemy. And according to the tutorial here, basically there are going to be 3 directions when it comes to walking. There's going to be a left walk, a right walk, and an idle was considered a state. So what we're going to do is we're going to create a new flow macro in the project folder and call it enemy walk. And this 3-directional movement will make sense here in just a second. So go to your macros, create a new bolt flow macro and call it enemy walk. And when we get into that, what we're going to do is we're going to put an input into that. And this is going to be very similar. Come on. Input. Nesting. There we go. So this is going to be very similar to the player movement macro. So just like the player has the x-axis that it's going to walk left and right, and it's going to jump up and down. If you wanted your enemies to jump, they would have a y-axis, but these enemies won't. They'll just have an x-axis. So what we need is we need an input into this macro, because we're going to chain it into a different macro system. So start with input, and we're going to give it a directional value. So on value inputs, there is going to be a direction. So just type direction there, and it's going to be a float. It's going to be a default value. So it has default value. And so basically, like I said, if it's 0, it's going to stand still. If it's negative, it should walk to the left. If it's positive, it should walk to the right. So in that enemy walk macro, let's calculate the direction that it's facing and move it that way. So let's start off by doing a get variable. And we want an object variable on that enemy. So we're going to call this speed. And if you remember, I don't think that has any kind of variables on it. So I think the fun part here is that it is creating that. Let's move ahead and we'll make sure. So I will definitely check that in just a minute. Multiply, and in this it is going to be multiply, and there is an idea here, or a function called normalize. So we're going to put that in there, and we're going to run the input into the normalize, and then we're going to multiply the speed times the movement of the graph. So just like the player had its own movement variable set inside the graph, meaning it wasn't outside of that macro, it was only in that one, we're going to do the same thing in this. So let's set variable, and it's going to be a graph variable, and we're going to call it movement, and this is going to update every frame. So we need to update that event, and so we'll call this. So we're going to calculate. We're going to figure out direction and movement of enemy. All right. So this is kind of like for me, it's kind of like, hey, what is this information? So I'm going to make it yellow, and you don't have to do that. Now we use the speed variable again because we want the player, though, to be a little faster than the enemy. We're going to set that object up right now. So go ahead and click on your enemy object, and we're going to apply a variable. So we're going to give this a speed, and we're going to say this is a float, and we're going to give it a 2. So we want the player to be faster. So the player, remember, the player's speed is set to 5, the enemy speed is set to 2. So if you're wanting to change that, that's where you do that. So we also want this enemy to change direction. Again, hit apply. on that. We want it to flip its what do you call it? Flip the macro whenever it, or not the macro, flip the sprite whenever it changes direction. It's much like the player. So go back to your enemy walk macro, and over to the right here, let's go back over here and let's say set local scale. I'm going to set local scale on that. On a, as you hear my kids crying in the background, my wife's there. I'm not just neglecting them. And so we just want it to flip on the X, right? So when it goes left, we want it to change to the left, and when it goes right, we want it to change to the right. So you do that again by the scale. And let me, just 1 second, we'll figure out what the normalize does, because I forgot. I'll be honest with you. I forgot what normalize does. Let me set this up. We're going to set that, and we're going to make it equal A and B. If A equals B, and B is 0, then if A equals B, then we're going to branch it off. It already was calling for that. We're going to make this a true or false statement, and if it's false, then we're going to flip the scale. If it's true, then we're going to be in good shape. So we'll just leave it alone if it's true. All right, so normalize. Let me go back in this and look real quick. Okay, so we just want we want it to stay at 1. We don't want it to go above 1, because we don't want whatever direction it's traveling in. So let's say it's traveling in 3 units per second. We don't want that to be multiplied times the speed. So what it's doing here is it's using this normalize to reset everything just back to 1. So it's kind of like absolute, but if you remember, absolute made something positive or negative. I'm sorry, negative, positive. It was always positive. It's an absolute number. And so the normalize keeps the positive negative, but it resets the value to 1 no matter what. So whatever direction it's going, however fast it's going, whatever, it's going to reset it to 1 so that it multiplies it times the speed, and it multiplies it against the speed, and then that movement is going to give it whatever that normalized value times speed is. So again, we put that under the enemy object variable. So the 2 times 1 is always going to be 2. So it's just a way to ensure that it never goes faster than it's supposed to. So we got the flip in there. It says that the equal sign here needs to be numeric. And from what I understand, there's another way to do that. You can flip that off and like grab this down here and then make this a float literal and just say, well, I'm going to make it 0. You can do it that way, or you can do it this way. It's showing you 2 different ways to do that. So we want A to equal B. Whenever A equals B, we want to we don't want to set that scale, right? We don't want to flip it. When it stops moving, we want it to stay looking in that direction. That's what that takes care of. So now once we got, let me fix that, because that's getting on my nerves. Yuck. I don't like sloppy things here. Okay, so let's call this set. Sorry, this is the flip sprite image, right? And then we are going to need to set the velocity. So let's start with a rigid body 2D set the velocity, or set the speed on that. This is another way to think of that. This is going to set the movement. Velocity is moving. And the XY here, so it's going to want to create a vector 2. And the X is going to be whatever the graph movement is. So get variable graph, and remember we already made one back there called movement, and it's just inside this graph. The reason we're doing that is because player has movement, enemy has movement. We want to keep it inside the graph. We don't want it to stretch across different objects. And that's important because sometimes you want enemies to have different speeds. So, and players to have different speeds, like the player's 5 and the enemy's 2, if you remember. So we want to get Y here, and it's a vector 2, and the Y is going to be get velocity, rigid body 2D. Alright, so what this is doing is it's saying we just want the X. We don't care about the Y for you because you're not jumping. We don't want you to have Y. We just want you to have the X. And so let me just real quick, let me fix my graphs here. Set local scale to go. Alright, so remember this is changing the image, and that's just saying once you're done doing that, make the object move. Now, again, so this is just getting the X value. So the movement is going to be whatever X is, and that's what we want you to move on the X. But we don't want the Y, and so what this is doing is saying, okay, hey, get the velocity for the Y. Get the velocity for the Y, and that's what the Y is going to be. So it's not going to change the Y. The X is changing, the Y is not. So that's how that velocity action is working. Now let's look at the animation, because we want it to animate whenever we move. So just real quick, let me go back and set the velocity. So change this, and I'll fix the colors in just a minute. I'll do it now. Whatever. You're doing something. You're changing the sprite. I'm gonna make you blue. You know what? Actually, I'm gonna make that purple because that kind of works with the animation. And this is get information. Do something with the sprite image or animation. Do something to the player or the character enemy. Make it move. And then now we need one more, which is animate. So let's set the float for animator, and we need the name and the value for that. And the name is going to be speed, because if you remember, the enemy here has a parameter just like the player, speed. We need you to go get that and set the value to absolute, not negative or positive, just positive. And get variable, get the graph variable that we made called movement. And that is going to set the animation. So let's set the float on that, and animation, and set that to purple because I like that. Makes sense to me. Whatever. It's kind of more pink than purple. I don't care. So essentially by the end of this thing, this is how big the enemy movement is going to be. So in the next tutorial, we'll look at patrolling. So join me in the next video.